Alright guys, come on. A university student is going to be in a much better position to leave the house than a 6-year-old kid. So, putting that aside, there's more than just acid chlorides and amides in this reactivity table. How are you going to memorize the rest of this? Well, you could use chemistry logic, or you can just use a memory aid. And when I go into exam, I usually think of it like this: double A T. So that's double A as in really good, not just one A, two A's, and the tea that you drink. For those of you who are too good for coffee and I only drink tea, yeah, that's it, double A T. So what's more reactive? Let me think. Let me go back to my memory aid. Let's see, double A acid, anhydride, thioester, ester, amide. There you have it, double AT. So now that we know these two concepts, we can move on. So here's our carboxylic acid that we're originally given, the acetic acid, and I still need nail polish remover. So how do I turn it into an acid chloride? Simple. Severe overdose of chlorine. I'm just joking. But that's a great way to memorize the reagent to turn this OH group, which is a really, really bad leaving group, into, a more reactive leaving group. Since they have the same sterics, they don't have a lot of this, they both have the same amount of carbons next to the carbonyl group, so we don't really need to worry about that. What we want to do, remove this. So let's quickly look at the mechanism. You're not gonna, it is unlikely gonna get tested on this, and I'll leave you to look at it, but I'll run through it really quickly. All you need to remember is that in order to get from the carboxylic acid to the acid chloride is a chlorosulfite intermediate, alright, which looks like this right here. So I'm just going to go through it really quickly. The double bond in the carbonyl is the one that it's the nucleophile, it attacks the S, alright? That's what makes your chlorosulfite intermediate. The H pops off, you got a little bit of a electron arrangement here, the chlorine pops off, and it comes back like a ninja and attacks from behind, combining with the carbonyl group. And thus, you get your acid chloride, the one we've been looking for, and SO2. Pretty simple. So, let's keep going. So I got my acid halide with a really good leaving group now, and ethanol. So, now it seems pretty easy. Before I had an OH here, bad leaving group, I smashed these two things together, it's not going to do much. So, when you're thinking about which one's the nucleophile in the ethanol, just think of it like this. In ethanol, you see an OH group. And CDO, just think of them like eyes. It's seeing this really vulnerable carbonyl group and this really good leaving group. And it's going to jump and make it attack. Alright? And all you need is a good median to combine the two. Textbook says to use pyrimidine. Alright? So just think of you're making something like a pyramid. Pyramids are stacks of blocks. You're stacking them, you're making something bigger, and bam, you get the ethyl acetate. You got the nail polish remover, so I can remove this stuff now. And just, if you're curious, it's actually called alcohol lysis. So lysis, as in you're breaking this alcohol, alright, you're combining it with this carbonyl group to make a bigger structure. Alright, let's recap really quickly. When you're doing nucleophilic acyl substitution reactions, if you don't want to read 20-30 pages on how to do this, just remember, use chemistry logic. Sterically unhindered. You want to look for the one with that's least sterically hindered, the one that doesn't have the bodyguards, easy to attack. Second thing, a good leaving group. Double A, tea that you drink. Double A, tea that you drink. So that's, acid halides, acid anhydrides, thioesters, esters, amides. Alright? And so we're going to go on. I know we've been giving you some easy quiz questions lately, so let's up it up a notch. This is an exam type question. We pulled it off an exam we found online. We thought it was a pretty good example. It's not too hard. It's something like you would get in a multiple choice, to be honest. So you got this. You got this molecule up here, alright? It has two carbonyl groups, alright? And you're mixing it with DMF, alright? And NaS H3. Alright? So what do you think is going to happen? Is the final product going to look like something like 1? You know, where the SH3, you know, replaces the Cl group? So this replaces here? Or is it going to look like 2? Is it going to replace this group right here? Or is there going to be no reaction? Because that happens too sometimes. So when you're ready, click 1 and we'll go through it.